Hello everyone, I am Rashim Rana, Assistant Professor in Information Technology Department of ABES Engineering College, Ghaziabad. Today we will discuss in this video NFA to DFA conversion with or without epsilon. This is the very basic topic of theory of computation. Let's start our topic. These are the contents: introduction to finite automata, types of finite automata, difference between NFA and DFA, conversion of NFA to DFA without epsilon, conversion of NFA to DFA with epsilon. Introduction to finite automata. Finite automata is a simple machine to recognize the patterns. It takes the string of symbols as input and changes the state accordingly. When the desired symbol is found, then the transition occurs. At the time of transition, the automata moves to the next state or stay in the same state. Finite automata has two states, that is, accept state or reject state. Basically, finite automata is an abstract model of computer. It works like the computer. As our computer works internally, it goes from one state to another state. Finite automata works as like the computer. This is the formal description of finite automata. A finite automata is a collection of 5 tuples: Q, summation, delta, Q naught, and F, where Q is the finite set of states, summation, finite set of input symbols, Q naught is the initial state, F is the final state, and delta is our transition function or mapping function. We can determine the next state using this function. Finite automata model. Finite automata can be represented by input tape and finite control. This is our input tape. Your device doesn't support and this is that. Our finite controller. Input tape. It is a linear tape having some number of cells. Each input symbol is placed in each cell. Finite control. The finite control decides the next state on receiving particular input from input tape. The tape reader reads the cells one by one from left to right, and at the time of only one input symbol is read. This is our input tape. This is our finite controller, and this is the read-write head. This read-write head reads only single input at a time. Types of finite automata. Finite automata is divided into two parts, that is deterministic finite automata and non-deterministic finite automata. Let's discuss about deterministic finite automata. The finite automata is called deterministic finite automata if there is only one path from a specific input from the current state to the next state. It can be represented as follows. A machine M, it carries 5 tuples Q, summation, delta, Q naught, and F, where Q is the finite set of state, summation is the finite set of input symbol, Q naught is the initial state, and F is our final state. Delta is the transition function. It is defined as Q into summation gives Q. Q is a state. Let's take an example. Q naught is our initial state and Q1 is our final state. If we apply input 1 to Q naught, it goes to Q naught, and if we apply input 0, it goes to Q1. In the same way, if we apply input 0 to Q1, it goes to Q1, and if we apply input 1, it goes to Q naught. This is our DFA. What is non-deterministic finite automata? Let's discuss that. The non-deterministic finite automata is an automata which contain more than one path. The finite automata is called non-deterministic finite automata if there are more than one path for a specific input from current state to the next state. It is also represented by 5 tuples Q, summation, Q naught, F, and transition function. Q is the finite set of state as same as DFA. Summation is the finite set of input symbol as same as the DFA. Q naught is the initial state and F is the final state. Delta. Delta is a transition function which defines Q into summation gives 2 raised to power Q. It means that it has choices. Let's take an example. Q naught is our starting state and Q2 is our final state. If we apply input 0 to Q naught, we have two choices. Either we go to Q1 or either we stay on Q naught. In the same way, if we apply input 1 on Q2, we have two choices. Either we go to Q1 or either we go to Q2. This is our NFA. So there is a difference between NFA and DFA. NFA has more than two choices and DFA has only single path. Let's discuss about the difference between NFA and DFA. DFA. For every symbol of alphabet, there is only one state transition in DFA. In NFA, we do not need to specify how does the NFA react according to some symbol. DFA cannot use empty string, but NFA use empty string. DFA can be understood as one machine, but NFA can be understood as multiple little machines computing at the same time. DFA will reject the string if it is end at other than accepting state. If all the branches of NFA dies or reject the string, we can say that NFA reject the string. Backtracking is not allowed in DFA, but backtracking is allowed in NFA. DFA is more difficult to construct, but NFA is easier to construct. Let's start our next topic, that is conversion from NFA to DFA. We have to follow some steps for converting NFA to DFA. These are our steps. Step 1, convert the given NFA to its equivalent transition table. Create the DFA start state. Create the DFA transition table. Create the DFA final state. Simplify the DFA. Repeat step 3 to 5 until no further simplification is possible. We have a NFA in figure 1. This is the transition table for this NFA. In this NFA, we have three state Q0, Q1, Q2. On applying input A, we get Q0, Q1. On applying input B, we get Q0. On applying input A on Q1, we get 5. On applying input B on Q1, we get Q2. And on applying input A and B on Q2, we get 5 on both steps. We take the first line of this transition table as it is, like that. Now find out the new state in this line. This is our new state. So take that state and apply input A and B on that state. That is Q0, Q1, input A. If we simplify that, we get Q0 A union transition function Q1 A. So on applying input A on Q0, we get Q0 Q1. Q0 Q1. And on applying input A on Q1, we get 5. That's shown in this diagram. Union 5. So finally we get Q0 Q1. On applying input B on Q0 Q1 B, we get, on applying input B on Q0, we get Q0. On applying input B on Q1, we get Q2. So we get a new state Q0. From this we get Q0. From this we get Q2. So this is our new set. Now we take that new set of state from this, apply input A and B, and we get these states. So Q0, Q1 and Q0 are both are the old state. So we have to stop here because no new state is present there. Now take that transition table and draw this diagram. So this is our final DFA. This is the process for converting NFA to DFA without epsilon move. Hopefully you understand that. Now convert the NFA to DFA with epsilon. For converting NFA to DFA with epsilon, we have to follow these steps. First step is we will take the E closure for the starting state of NFA as a starting state of DFA. Now what is the E closure? If we have state 1 and this is our state 2, this is the arrow, there is a path. On that arrow, if we have this symbol, so we have E closure for state 1. From state 1 to state 2, we go through this E move. This is the E closure of 1. In step 2, find the states for each input symbol that can be traversed from the present state. That means the union of transition value and their closure for each state of NFA present in the current state of DFA. Step 3, if we found a new state, take it as a current state and repeat step 2. Step 4, repeat step 2 and step 3 until there is no new state present in the transition table of DFA. Step 5, mark the states of DFA as a final state which contains the final state of NFA. Let's take an example. This is our NFA diagram. These are the E moves, epsilon moves. So let's first of all find the E closure of Q node, that is the starting state. In closure, we have a rule. E closure of Q node gives Q1 state and Q2 state, and Q node itself also carry in the E closure of Q node. E closure of Q1. From Q1, we don't have any E closure, so we have to write the Q1 itself. Same in the same way, E closure of Q2 gives Q2 and E closure of Q3 gives Q3. E closure of Q4 gives Q4. So these are the E closure of all the states. Now, E closure of Q node gives Q node, Q1, Q2. There are 3 states present. So we can represent this with A. Now, apply transition on state A. We are applying input 0 on A. So what we have to write? E closure transition A, comma, input 0. So A contain 3 states, Q0, Q1 and Q2. E closure, if we simplify that, transition apply on Q0 with input 0, on Q1 with input 0 and on Q2 on input 0. So Q0 gives 5, this gives 5, Q1 gives Q3 and this also gives 5. So finally we get only Q3. So E closure of Q3 is Q3 itself. We call Q3 as the new state B. Now apply input 1 on set A. What we are getting? Q0 1, Q1 1 and Q2 1. We get on Q0 no 1 is applied. On Q1 no input 1 is applied. On Q2 input 1 is applied and we get Q3. So that is the Q3. Now E closure of Q3 is Q3. So again it represented with B. Now take the next set B. Apply input 0 on that. E closure of this gives 5. Now take input 1 and apply on B. E closure of Q3 input 1 get Q4. So Q4 is our next state. it is represented with C. Now apply the same rule, input 0 and 1 on C, and but we are getting 5. No new state is there. So we have to stop there. And this is our final transition table, which contain only 3 state A, B, C, input 0 and 1. And this is the final diagram of DFA, which we are getting from NFA with epsilon move. So C is our final state. Why? Because C contain Q4. So this is our final state. Hopefully you understand that. I didn't understand that. These are the references from where I take the content for this video. Thank you.